Good morning, class. Okay, so today we're going to go ahead and start our unofficial first math virtual meeting. I'm going to go ahead and give you the notes and our language of the discipline and problem of the day. And then you guys will do a guided practice, and then you guys are going to be able to solve your independent practice. So we're going to start off with our title. Our title for today is Line, Segments, Rays, and Angles. Today is a beautiful day of March the 30th of 2020. And our objective is TEKS 4.6a. TEKS 4.6a. Identify points lines, line segment, rays, angles, and perpendicular, and parallel lines. Okay, that's objective. Objective TEKS 4.6a, identify points, lines, line segments, rays, angles, and perpendicular and parallel lines. So what is my objective trying to tell me, guys? So what it's trying to tell me is that we're going to go ahead and identify, that's our verb, right? We're going to identify, don't forget to highlight our objective, right? We're going to identify the different names of how geometric, we're going to identify how the lines and everything else looks in a geometric figure or in geometric terms. With that, we're going to quickly jump into our language of the discipline for today. Our language of the discipline will start with a line segment. With line segment. Okay, what is a line segment? Is a part of a line with two endpoints. Okay, so a line segment is a part of a line with two endpoints. So usually it will look like this. It will have a period or a dot, and then it will have a line, and it will end with another dot. And they will have letters on each dot, for example, G and R. So this one is called line segment GR. Okay, so for that one is line segment GR. Awesome. Okay, don't forget to highlight your first language of the discipline, line segment. Excuse me. Okay, next one we're going to go ahead and move on with is ray. A ray. A ray is a part of a line that has one endpoint and continues on forever. in one direction. Okay, so what does this mean? How does this look like? So, again, we're going to go ahead and draw our endpoint. So this is our endpoint, right? Or our period, our endpoint. Let me go ahead and pause real quick. Sorry about that. I had to adjust my camera so you guys will be able to see what we're doing. So that is my endpoint, right? These are called endpoints. Let's go ahead and label them. They're called endpoints. Okay, so we do our endpoint. And according to what a ray is, it says is a part of a line that has one endpoint and continues on forever in one direction. So again, we're going to call this endpoint letter N, right? We're going to go ahead and continue the line in one direction. Now, there can be another endpoint on this end, and we can call it O, right? Does this mean we can just stop there? No, it says continues on forever in one direction. So we go from one endpoint, we pass the other endpoint, and it continues on forever. So that is why we put the arrow like that. So this one is called ray and O. Ray and O. Okay? Now, we're going to go ahead and introduce four new languages of the discipline. Okay, 4 new languages of the discipline that have to do with angles. Don't forget to go ahead and highlight the word ray because we're going over rays, right? So we're going to go ahead and start. We're going to call this angles. Our languages of the discipline with angles, okay? So our first one that we're going to go ahead and call is a right angle. A right angle, excuse me, excuse me, is a square corner. Okay, so for this one, I'm going to pause again real quick. Sorry about that. So for this one, it's a square corner. This one will look like this. Okay, so the example is it has a square corner. So our rectangles and our squares, those have square corners, right? So they form what we call a right angle. So our right angles will look like these right here, and they will usually have that little square on the corner, signifying that it is a square corner. Okay, so usually our right angles will look like this. Our next one is called an acute angle. Acute angle. The acute angle is open less than a right angle. Okay, so for acute, it sounds like cute, right? Like cute little things. So acute, when you see the word acute angle, imagine that you're talking about something small. So we're going to go ahead and draw a right angle, right? That's a right angle. So if it's less than a right angle, it means that the other line should be what? One line is obviously this one, right? We have one right here. The other line should be less than this line. So anything less than that line right there, this line segment right here, it will form a an acute angle. So if I do this, that forms an acute angle, okay? It forms an acute angle. Now, let's try another example. We draw our invisible lines for our right angle. We draw the first line, signifying this is where the our first angle, acute angle, will start. Can this be an acute angle? Think about it for a moment. Now, it's open less than a right angle. Is this one open less than a right angle? Yes, it is. So yes, this is also an acute angle. One more example before we move on. Let's go ahead and draw our imaginary lines for a right angle. We draw our first line segment. Now, is this an acute angle? Think about it for a second. Think about it for a second. Now, remember, an acute angle is open less than a right angle. This is where my right angle is. Is this opened more than my right angle? It is. So this one is not. That one is not an acute angle, okay? Okay, our following angle is called an obtuse angle. Obtuse angle, okay? An obtuse angle is open more than a right angle, but less than a straight angle. Okay, well, that sounds a little bit complicated, Mr. Silva. Well, don't worry about it. Let's go look at our examples. Okay, our first example, we're going to go ahead and draw our imaginary right angle, right? That's our imaginary right angle. Now we will draw our first line segment to start our angle. Now, an obtuse angle says it's open more than a right angle. So do I need to open it anywhere in between here? Do I need to open my next line anywhere in between here? No. If we do that, it's called an acute angle, which is the one we previously discussed. We need to open it more than the right angle. So it has to be above it, right? More in front of it. So here, if we do this right here, this one will be considered an obtuse angle. Okay? Another example, we can draw our imaginary right angle. We draw our first section right here, right? And we said that it has to be more than. Can this be an obtuse angle? Yes, it can. It still can be an obtuse angle, okay? Then one more example, and I'm going to draw it underneath right here. We're going to draw our imaginary right angle. Can this be an obtuse angle? It's more than the right angle. No, this one cannot be an obtuse angle. Why? Because that will lead us to our next and final language of the discipline, a straight angle. Okay? So, a straight angle is an angle that forms a straight line. Okay, so remember to highlight straight angle. Now, a straight angle is an angle that forms a straight line. So basically, we just draw a straight line. This one is a straight angle. Now you see why an obtuse angle cannot be straight like this because then it will form into a straight angle. Okay? Okay, I'm going to give you a quick hint right here. Hint, hint, hint. Angles are formed by two intersecting lines or by rays that have the same endpoint. Okay, so you were able to notice that all of these angles that we covered had a connecting endpoint, right? Sorry, they had a connecting endpoint. So in angles, we're able to see that they also have endpoints. And this is where our angles form. Okay? So we see that we do also have endpoints in our angles. Yeah? Okay. So we're going to go ahead and continue with our guided practice. As you can tell, I wrote already my guided practice in my notebook. Again, you guys don't have to write this down, but if it helps you, you're more than welcome to, okay? So we're going to go ahead and start with this one. Number 1, it says, in 1 through 4, use geometric terms to describe what is shown. So first of all, what is a geometric term, guys? What is it? Well, a geometric term is everything that we previously discussed. Our language of the discipline: a straight angle, obtuse angle, a line segment, a ray, a right angle, and an acute angle. Those are called geometric terms, okay? They refer to something that forms a shape or a line, okay? So for number 1, if we look at number 1, what geometric term best describes that one? I'm going to give you some time. Okay, so if you go back to your notes, and look at the examples I gave you, right? Which one looks like that one? This one right here. And what is that called? A line segment. So if we go back here, this one's called a line segment. Now let's look at number 2. Does anybody know what geometric term that one is? It looks like I have a little square right there. So it's going to be an angle, particularly a right angle, okay? Go back to the video if you have to go look back at those notes, okay? And if you don't want to go back to the video, just simply grab a piece of paper and write the notes like normal. Now let's look at this one. Excuse me. Let's look at this one. This one seems to have 2 endpoints, but it doesn't stop on one. It keeps on going. So I have an endpoint and it keeps on going forever. That one is called a ray. Okay, it's called a ray. Now let's go look at this one over here, number 4. It looks like I have 3 endpoints. Okay, it looks like there's 2 rays connected to one endpoint. It looks like it's an angle. Well, if you don't know your angles just yet, then go draw the invisible right angle on it. So this is my right angle, and the other ray is going in between them, and it's less than the right angle, then it's an acute angle, okay? Okay, number 5. What geometric term describes a line that has only one endpoint? It only has only one endpoint. So draw it. It has a line. It's a line that has only one endpoint. Let's go see. Maybe we go back to our notes and look at the ones with lines. Let's go see. This one's a line segment. It's a part of a line with two endpoints. So no, it can't be a line segment. It's part of a line that has one endpoint and continues on forever. Well, if it has only... we lost it. There it is. If it has only one endpoint, then that means this one can also be a ray. Okay, so draw it out if you have to. So if it only has one endpoint, it's called a ray. Okay, number 6. What geometric term describes a line that has two endpoints? So now I have two endpoints, just like that. Well, according to what we just saw, if it has two endpoints, it's a line segment. Okay, the next one that we're going to be looking at, it's number 7. Which geometric term describes two edges that form a square corner? When we're going over this one, remember number 2? I said when they always put a little square corner. If it forms a square corner, it's what type of angle? A right angle. So here, if you draw it, then it's two lines, right? It says which geometric term says two edges. So it's an edge. It does a square corner, then it must be a right angle. Okay, so that is our end of our guided practice. I hope this helps, and if you have any questions, please do let me know.